So listen students, next we can see the impulse response problem if they given the circuit. Okay. So if you see why I have made the division here means, so இங்க divide பண்ணியிருக்கேன் அப்படிதானே. So எதுக்கு வேண்டினா, so both are same problem. What is the difference means, இங்க x of t is equal to e power minus t by rc. Here x of t is equal to t into e power minus t by rc. Okay. So both have the same steps. Okay, so if you see this problem in the low pass filter RC network shown in figure, determine the output. So I said you in impulse response, input is x of t and output is y of t. Okay, impulse response is h of t. Okay, so remember that. Okay, and here current is I of t. Output response for an input signal x of t is equal to e power minus t by rc. So this is also same question. What is the difference means, only the x of t value is vary. Here x of t is e power minus t by rc. Here x of t is t into e power minus t by rc. So now we can see the diagram. So it is a low pass RC network. So we know the low pass RC network means, so it is a R and C are series in nature. So it is a low pass RC network. Okay, so it is given. So from the diagram, so first apply the KVL, that is Kirchhoff's voltage law. You know what is Kirchhoff's voltage law? So we have studied in circuit analysis. Okay, so first here we are going to find this value, that is x of t. Okay, so if you take it is one of the voltage value. So here it is a current direction. Okay, so first it is meeting to minus value. So while writing the equation, how will you write here? Minus means x of t. Okay, so minus x of t on here. So here if you are writing equation for resistor means it is dropping. So we will write resistor drop minus r into, so you know resistor voltage is I into r. So I of t into r. So here also capacitor also there's a drop in current. So here what is the capacitor voltage? The formula is 1 by c integral I of t dt, which is equal to 0. So it is the Kirchhoff's voltage law for this equation. So we want to find the value of x of t. So x of t is equal to r into I of t plus 1 by c integral I of t dt. Okay, so now here we have first apply the KVL at the input side. Now you want to apply the KVL at the output side. So here the output value, so output across la என்ன இருக்கு, நமக்கு கெப்பாசிட்டர் மட்டும்தான் இருக்குது. ஸோ கெப்பாசிட்டரில் உள்ள வோல்டேஜ் தான் அவுட்புட் வேல்யூ. ஓகே, ஸோ ஹியர் input means it has one closed circuits. If you see the output side, only it has y of t. So y of t வந்து எதுக்கு acrossல இருக்குன்னா கெப்பாசிட்டருக்கு acrossல. So you want to write the voltage across the capacitor equation, that is y of t is equal to, what is the value, 1 by c integral I of t dt. Okay, so it is the voltage across the capacitor. So now apply the Laplace transform for this, Fourier transform for these both equations. Okay, here we are applying the Fourier transform. So Fourier transform means here the Fourier transform of x of t is, that is time domain is changing to the frequency domain. So here we are changing t as omega, so x of j omega. Okay, so here r into I of t, if you apply Fourier transform for I of t, it is capital I of j omega. Okay, so here the integral value means the for Fourier transform, that is similarly in Laplace transform we will write, if it is for applying the Laplace transform for integral of I of t means what is the value, I of capital I of s by yes. Okay, Laplace transform of integral, that is I of t value we will apply, and that is capital I of s by s, that is integral. Laplace transform of integration is 1 by, we will write as 1 by s form. Okay, so here also in the place of s we are replacing j omega, so I of j omega by j omega. So here also the same steps we are proceeding. Okay, so இது வரைக்கும் இது ரெண்டுலேயுமே same steps தான். So only the x of t value will be varied. Okay, so same steps. So for that question also, so here also x of j omega taking I of j omega is common இருக்க வேல்யூவை வெளியில் எடுத்துருங்க. So the remaining value is r plus 1 by c omega. In this question also same thing, this step, இதே step தான் இங்கே வரும். So if you see from this value you can find, if you take, so it is x of j omega input value அப்படிதானே. So இப்போ output value you want to take the equation 2, equation 2லேருந்து y of j omega, that is you are applying the Laplace Fourier transform, and you got y of j omega as this value. Okay, here also same thing. So now, what is our impulse? Sorry, it is a transfer function, correct? Impulse response is h of t. So it's our transfer function for Fourier transfer. So h of j omega is y of j omega by x of j omega. What is our question? Question la enna find panna ketirukanga. In our question, they have asked to determine the output response. Okay. So output response find பண்றதுக்கு வேண்டி நம்ம என்ன பண்றோம்? Transfer function எடுத்து ஸோ அதுலேருந்து y of j omega கண்டுபிடிச்சிட்டிங்கன்னா easily you can find the output response y of t. Okay, so now in order to find y of t, we are taking transfer function h of j omega, that is y of j omega by x of j omega, substitute that value. So from this term, taking I of j omega outside, okay, I of j omega எடுத்தீங்கன்னா cancel ஆகி you get this value. Okay, h of j omega நமக்கு என்ன கிடைச்சிருக்கு? 1 by rc j omega plus 1. Here also same thing. Okay, so h of j omega இந்த question same ஆத வந்திருக்கு. Okay, so both are same value. So from this network, you can take rc value as common. இதில் இருந்து rc காமனாக வெளியே எடுத்துக்கோங்க. Then what is the value? j omega plus 1 by rc. Here also same thing, j omega plus 1 by rc. So now if you take 1 by rc to the numerator, it become j omega plus 1 by rc. Okay, so it is our h of j omega. Same thing தான் இந்த ப்ராப்ளத்தில் நமக்கு h of j omega value கிடைக்கும். Okay, so both h of j omega values are same. So only which values vary for both the questions means, if you see in this question இங்கே x of t value என்ன கொடுத்துருக்காங்க? e power minus t by rc. இங்கே x of t value என்ன கொடுத்துருக்காங்க? t into e power minus t rc. Only the x of t value. So இதுக்கு பிறகு steps நமக்கு மாறும். So now you want to apply Fourier transform of x of t. So if you apply Fourier transform of x of t, what is the value? X of j omega is equal to 1 by j omega plus 1 by rc. Okay, that is here what is the value? E power value. So in Laplace transform, what is e power minus st value? If you apply Laplace transform for this value, what is the answer? 1 by s plus that is 1 by s plus, sorry, it is e power minus at. Okay, not st, at is you will get 1 by s plus a. Similarly here also e power, in the place of a here 1 by rc. Okay, 1 by rc. So here we here 1 by s plus a, இங்க s இருக்க இடத்துல j omega போடும். Fourier transform same thing, j omega plus 1 by rc. Yeah, so now we need output response. What is output response? Y of t. So we get the value of x of j omega and h of j omega. So இங்க x of j omega என்ன கிடைக்கும் நமக்கு? t into e power minus t by rc. So if you apply Fourier transform for this function, we get 1 by s plus a. In Laplace transform, we get 1 by s plus a the whole square. Here in the place of s, you want to transfer this to j omega. But j omega plus 1 by rc whole square. But x of j omega for this question also we get, for this question also we got. So now easily you can find the value of output response y of t. What is output response y of t? Y of t கண்டுபிடிக்கணும்னா y of j omega தெரிஞ்சுனா ஈஸியாக inverse Laplace transform apply பண்ணி y of t find பண்ணிக்கலாம். So now y of j omega is h of j omega into x of j omega. We get the value of h of j omega, x of j omega கிடைச்சாச்சு. Multiply both the values, so you get this value. So now in order to take the inverse Laplace transform, say it is a constant, take outside. What is it? So here we have seen the same thing. Okay, same value. So here also if you take inverse Fourier transform for this function, you get t into e power minus t by rc. So 1 by Fourier transform இங்கே அப்ளை பண்ணும்போது நமக்கு என்ன கிடைச்சிருக்கு? இதுக்கு இன்வர்ஸ் வேல்யூ தான் இங்கே கிடைக்கும் நமக்கு. ஓகே, ஸோ y of t is equal to 1 by rc t into e power minus t by rc. That is a Laplace transform of, if you take the inverse Laplace transform of this value, get 1 by j omega plus a squared is t into e power minus at. Sorry, inverse Fourier transform. Okay, so Fourier transform of this value is 1 by j omega plus a the whole squared is t into e power minus at. Can you understand? So now if you see here also we get h of j omega and x of j omega. So now multiply these two values. So you got j omega plus 1 by rc the whole square. So inverse Fourier transform of 1 by j omega the plus a the whole cube is, what is the value? T squared by 2 into e power minus at. Okay, so you get this value. So this is the formula for inverse. If you apply the inverse value of Fourier transform means you get here also inverse Fourier transform. If you apply means you get t squared by 2. Okay, this constant term RC e power minus at. So here a value is 1 by RC into t. Can you understand? Okay, same procedure for both the problem, only x of t value is different. Okay, so by using this you can easily find the value of the output response, that is y of t. Okay, so it is you can derive from the impulse response value, that is transfer function value.